Today we are going to explore a fundamental concept in mathematics, that is limits and integrals. Given question is limit n tends to infinity n factorial over n raised to the power of n whole raised to the power of 1 over n. Not only that, I will also show you a simple trick to write natural log values from 1 to 10. So stay tuned until the end of the video. First, let us consider this term as some variable a. Let's take a equal to n factorial over n raised to the power of n whole raised to the power of 1 over n. In the exponent we have a n term, so better you take the log on both sides. Let's take natural log on both sides. Log a equal to log n factorial over n raised to the power of n whole raised to the power of 1 over n. 1 over n is in the exponent. Now it is in the form of ln of a raised to the power of m. We can write this as m times ln a. So we can write this as 1 over n times ln of n factorial over n raised to the power of n. In our given question we have a limit. So let's take limit on both sides. So limit n tends to infinity ln a, that is equal to limit n tends to infinity 1 over n times ln n factorial over n raised to the power of n. Now observe this n factorial over n raised to the power of n term. N factorial is nothing but 1 times, 2 times, 3 times and so on n over n raised to the power of n is nothing but n we have to multiply n times, isn't it? So we have to write n times and so on n. This simply we can write it as 1 over n times 2 over n times 3 over n and so on n over n. So let's take this limit n tends to infinity, limit n tends to infinity ln a equal to limit n tends to infinity 1 over n ln of what we have 1 over n times 2 over n and so on n over n, isn't it? So it is in the form of product form in natural log. This product logarithm we can write in terms of addition, that is log of 1 over n plus log of 2 over n and so on plus log of n over n. We can simply write this as summation of ln. Just consider numerator as some variable k. So this k starts with 1 to n. So let's write n here, and over denominator we have only n. So this logarithm 1 over n plus log of 2 over n and so on log of n over n, we can simply write it as summation k equal to 1 to n ln of k over n. Still we have 1 over n, limit n tends to infinity. This is the right hand side part. In left hand side, limit of n tends to infinity ln a, this also we can write it as ln of limit n tends to infinity a. Both values are same. Now let's take only the right hand side part. This summation, observe the limits, so k equal to 1 to n. So it is a finite. According to definition of definite integral, we can write this as integral ln x. But is this correct to change summation into integral? Here is an example to prove this transformation. Now what we have summation k equal to 1 to 10 ln k. So this we can write it as ln, this k value starts from 1 to 10. So you have to write ln 1 plus ln 2 plus ln 3 and so on ln 10. So what is the value of ln 1? The value is 0. ln 2 the value is 0.693 and ln 3 the value is 1.08 plus and so on ln 10 the value is 2.302. After adding all this, then you will get 15.1. So here the summation we written as integral ln x. Same like that. Now we have to take integral ln x dx. So the limits are 1 to 10. Integral ln x dx, the value is x ln x minus x, isn't it? So the upper limit is 10, lower limit is 1. So let's substitute upper limit, that is 10 times ln 10. ln 10 the value is 2.302. So let's write 2.302 minus we have x. So just write x. This is the upper limit. After simplifying, 10 times 2.302, which gives 23.02. minus 10 which gives 13.02. This is the upper limit. Still we need to apply the lower limit. Minus lower limit is 1 times ln1. ln1 the value is 0. So this is 0. ln1 minus 1. ln1 the value is 0. So 1 times 0, this term is turned into 0. Minus term minus 0 minus 1 which gives minus 1 only. 13.02 minus term minus which gives plus. So it gives 14.02. Isn't it? So when you do summation, the value is 50. When you do integral, the value is 14. That means summation is approximately equal to logarithm integral ln x. So that's why the summation we can write it as integral ln x because it is approximately equal. So instead of the summation, I am writing integral ln x. Now what about this 1 over n? To observe this 1 over n, we need to draw a graph. So if we draw a graph for this function, the graph is showing like this. So the summation, the first term is 1 over n. The second interval is 2 over n, and so on. The last is n over n. That means 1 over n represents the width of each subinterval, isn't it? So this also known as dx. So instead of 1 over x, I am going to write dx. Now observe limit n tends to infinity. So now here our lower limit is 1 over n, isn't it? So 1 over n. So substitute n as infinity. So that is 1 over infinity. 1 over infinity is nothing but 0. That means our lower limit turn into 0. Now take the upper limit. What we have? N over n. So n over n is nothing but 1. So that means the upper limit is 1. If you apply n as infinity, the lower limit is 0, the upper limit is 1. So we apply the limit n tends to infinity. 1 over n is nothing but width of each subinterval, and the summation we can write it as integral ln x. Turns into integral 0 to 1 ln x dx. This is the right hand side. And left hand side we have ln of limit n tends to infinity a, that is equal to integral 0 to 1 ln x dx. This we can write it as integral 1 times ln x dx, isn't it? Now you have to use the u product rule. It is in the form of integral u times dv. The formula is uv minus integral v times du. Here u is nothing but ln x and dv is 1 times dx. If u is ln x, then du is 1 over x. If dv is 1 times dx, then v is x. So let's substitute all the values here. So integral 0 to 1, u is nothing but ln x, dv is nothing but 1 times dx, which is dx. That is equal to, what's the formula? uv. What is our u? ln x. What is our v? X. So I am writing in front x ln x minus integral v is nothing but x times du is nothing but 1 over x dx. After cancelling, then you will get integral 1 times dx, which gives x only. So this is x. So now apply the limits. The lower limit is 0, upper limit is 1. Let's apply the upper limit first. So 1 times ln 1, the value is 0. So let's write 0 minus 1. So the upper limit turns into 0 minus 1, which gives minus 1. This is the upper limit. Minus lower limit is 0 times ln 0, which gives 0 only, minus 0. So lower limit all is 0. So we left only minus 1. Let's take minus 1. So this value is minus 1. Here we have taken natural log. That means here base is e. Now it is in the form of ln of a with base b. If that is equal to some constant, this logarithm function we can convert in terms of exponential function. That is a equal to b raised to power of, that means base raised to power of some constant. Similarly, here our a is limit n tends to infinity a, that is equal to b raised to power of, that means our base is e raised to power of minus 1. E raised to minus 1 we can write as 1 over e. At starting we consider a as n factorial over n raised to power of n whole raised to power of 1 over n. Let's take that. So we consider a as n factorial over n raised to power of n whole raised to power of 1 over n. So limit n tends to infinity n factorial over n raised to power of n whole raised to power of 1 over n. The value is 1 over e. Now it's time to share a handy trick that will help you in your natural log problems. First, you have to take the common log values from 1 to 10. In one of my previous videos, I explained how to remember log values from 1 to 10. If you are new in this channel, I would highly recommend you to watch that video. Now come to the natural log. To find the natural log from the common log, the formula is ln x equal to 2.303 log x. Suppose if you want to find ln 1 value, so let's take x as 1. So then ln 1 equal to 2.303 times log of 1. So log of 1 the value is 0. So that means ln 1 the value is 0. Let's take x as 2. So natural log of 2, that is equal to 2.303 times log of 2. Log of 2 the value is 0.30. After doing this multiplication, then you will get 0.69. So the natural log of 2 the value is 0.69. Similarly, ln 3, that is equal to 2.303 times log 3. Log 3 the value is 0.47. Let's take 0.47. After multiplication, you will get 1.08. Like that, you can simply find log 1 to log 10 values. This approach is much simpler and more spontaneous than trying to memorize natural log values. I hope you like this content. If you like this content, please subscribe to my channel and give your valuable comments in the comment section. Thank you for watching.